6a. So when a is equal to a negative 1/2, b is equal to a negative 1 over 6 times a negative 1/2, which is equal to a negative 1 over a negative 3, which is equal to a positive 1/3. But when a, what?
Negative.
Jonathan, you're jamming out to some tunes there.
Negative.
Jonathan, you okay?
Which is equal to a negative.
Why am I hearing myself? 6 over positive 1/2 is equal to a negative 1 over 3. So when a is equal to a negative 1/2, b is equal to positive 1/3.
What would you little maniacs like to do first?
When a is equal to positive 1/2, b is equal to negative 1/3. Jonathan, you're killing me. Your mic's on.
Wait, how long? No, how long? No way, wait. How long, Mr. Higgins?
Oh, it
my God.
happened. It happened. And, you know, it is what it is.
Oh my God, no.
Oh, yeah. I even heard myself.
Oh my God,
So I don't know what you're doing over there, but, you know, whatever. Didn't sound mathematical.
no.
Number 4, any questions?
Okay, I have a question in the same problem.
Mhm.
So in the book, they wrote 1/2 minus 1/3 I. So how do we know?
Oh, because
So
they
like,
said
how-
evaluate the following answers and check your answers with, I just didn't finish. I just gave you the A's and the B's.
right, but
They
the
said,
book-
so they said, show it, right?
yeah,
So I need, and they wrote what? Z is equal to what?
they wrote plus minus, and then in parentheses they wrote 1/2 minus 1/3 I.
Right.
But-
Because if you notice, I have a plus or minus 1/2, but I also have a plus or minus 1/3. So it's 1/2 plus 1/3 I.
Yeah, but how do we know that the 1/3 has to be minus in the problem? Like, is it minus because in the problem the I was negative? Is that why?
Yes.
Okay, all right.
And when A is negative, B is positive. And when A is positive, B is negative. So you have to have opposite signs on your A and your B. Does that make sense?
Yes, thank you.
Okay. Yep. Okay. Any questions on 4?
Could you do 4B?
4B. 4B. So I have Z conjugate to the n equal to Z to the n conjugate, where n only belongs to the positive integers. Okay, so what is Z? We're going to let Z be A plus BI. So Z conjugate is going to be A minus BI. So A minus BI to the n, and then we have A plus BI to the n, but whatever I get here, I'm going to conjugate it. Okay, so what they're talking about here, every time, and we did a little experiment, every time that we took and expand the binomial expression. It says over here in the investigation number 9, it says let Z equal A plus BI, which we did. You learn that the binomial expansion of A plus B to the n, where n belongs to the natural numbers, use the binomial expansion and use your results about powers of I from question 2 to find Z to the second and Z to the third. Okay, so what is Z to the second? So what we're going to do is I'm just going to establish a pattern over here on the side. So Z is equal to A plus BI. Z to the second is going to be A plus B to the I, A plus B to the I. So this is going to be A squared plus 2ABI plus BI squared, which we know is going to be A squared minus B squared